Where do math symbols and terms come from? In this video, we'll dive into the interesting origins of the terms in mathematics, tracing their roots from ancient Greece and various cultures from around the world and carrying their legacy to this day. Let's start with the word mathematics itself. The word mathematics traces its origin to the ancient Greek word mathema, which just meant knowledge. From this word we get mathematikos, meaning what one gets to know. We also get the word polymath from the word mathema, meaning someone who is good at many things, not just mathematics. Then the Greek word mathematikos became mathematica in Latin. Mathematica was a plural noun, which is why mathematics has an S at the end, even though we use it as a singular noun. And as the word reached English, it replaced the old English word for mathematics, reamcraft. Now let's move on to the basics in maths, starting with the numbers. The English words for numbers from 1 to 10 can be traced back to the oldest ancestor of English, which is the Proto-Indo-European language. This is a language which used to be spoken around 6,000 years ago in somewhere near modern-day Ukraine, and it spread out all the way from Europe to India. All these languages that evolved from Proto-Indo-European are called Indo-European languages. I find it quite fascinating that all these diverse languages from across the earth have the same origin. You can still see some vague similarities between the Proto-Indo-European numbers, English numbers, and Indian languages like Sanskrit and Hindi. And what about the next numbers? Why do all the numbers from 13 to 19 end in teen, but not 11 and 12? This quirk is because of Proto-Germanic, a branch of Indo-European which is the ancestor of Germanic languages like German, English, Dutch, Swedish, etc. 11 and 12 were once Einlif and Twalif. Lif here meaning to leave. So Einlif is 1 left after subtracting 10, and Twalif is 2 left after subtracting 10. This is why you can see this pattern in every Germanic language, but not in other European languages such as French, Italian, Russian, and so on. And as for 13 to 19, as you have probably guessed, it comes from 3 plus 10, 9 plus 10, etc. Teen is just an old inflected form of the word 10. The words 20, 30, and so on till 100 and 1000 comes from Proto-Germanic. For example, 20 can be traced to Proto-Germanic twain tirvis, coming from twain meaning two and tiras meaning group of 10. The number 0 was in use in Europe up until about the year 1200 AD, which is why Roman numerals don't have a 0. But 0 was being used in India at least since the year 600 AD, not just as a placeholder but as a genuine number with its own properties and rules. The word for 0 also originated from India. They use a Sanskrit word shunya, meaning nothingness, which evolved and became sifr in Arabic and zephyrum in Latin. And it finally evolved into the word zero in English. If you have seen the symbols for numbers used in Europe and the Arab world, you have probably noticed that they look quite similar. That's because all these symbols trace their origin back to one place, India. Around 1,000 years ago, the scripts for numbers in India diverged. In India, they evolved and eventually became the digits used in the Devanagari script. While the old forms continued into the Arabic world, the Eastern Arabic numerals for the digits eventually evolved to become the ones used in Arabic today. The Western Arabic numerals were adopted by Europe, and it evolved to be the numerals currently used in English. The order in which these symbols are written is different from Roman numerals because this is what's called a positional numeral system. In the Roman numeral system, there are 7 symbols that are usually used. 1 is represented by I, 5 by V, 10 by X, 50 by L, 100 by C, 500 by D, and 1000 by M. To add a number, you put a symbol on the right side, and to subtract a number, you put a symbol on the left side. Since 2 is 1 plus 1, its symbol is II. You can't put 4 of the same symbols in a row, so you can't represent 4 by writing III. It's written as 5 minus 1, which is IV. Similarly, you write 8 by the symbols VIII, and since you can't put VIII, you write 9 as 10 minus 1, which is IX. The problem with Roman numerals is that there is no way to represent fractions, and you have to come up with more and more symbols as you count higher. You can do long division with Roman numerals, but it's really difficult. In the Hindu numeral system, if you want to write down 3294, for example, you just count how many thousands, hundreds, and tens there are. It is 3000 plus 200 plus 90 plus 4. So you just put the symbols 3294. The positions of the symbols tell you the number of ones, tens, hundreds, etc. So with just 10 symbols, you can write down any number as high as you want till infinity. This is why it's a base 10 or decimal system. Decimal comes from Latin decimus, meaning tenths. The word infinity also comes from Latin, from the word infinitas. The prefix in means not, finis means end, and tas is a suffix in Latin similar to nes suffix in English. So infinitas means unlimitedness. The English word finish also comes from the Latin finis. With the arrival of the Hindu numeral system and 0 came the idea of decimal places, which are the digits to the right of the decimal point. Multiplication or division by 10 just means shifting the decimal point one place to the left or right. And then we got exponents, long division, logarithms, calculus, each idea built upon what came before. But most of those ideas had to wait for the idea of positional numeral system and 0 to show up. And what about the word number itself? Where does that come from? The word number traces its origin to the Latin numerus, which is ultimately derived from the Proto-Indo-European word nem, meaning to take, share, or portion, and seems to have been originally associated with the division of land. And the word nem is also the ancestor to so many seemingly unrelated words to number, like nimble, referring to one who is quick to take his share. Numb means seized or taken. A nomad is a person who wanders in search of pasture land. And there are so many technical nom words. Binomial meaning two-numbered, astronomy meaning numbering or allotting the stars, economy, autonomy, and so on. German and some other Germanic languages still uses the word nehmen meaning to take. Now let's focus on the basic symbols. Starting off with the plus symbol. In the past, mathematics used to be written in full sentences. So instead of writing 1 plus 1, you would write 1 and 1, which you wrote like this in Latin. Here, et means and the symbol I is Roman numeral for 1. To make the plus sign, all they did was drop the E in et and leave the crossed T. By coincidence, it also gave us the and symbol, also known as the ampersand. It's a combination of E and T. You can see it a bit more clearly in other fonts. The word ampersand itself is an alteration of et per se and, meaning et by definition and. Anyways, 1 plus 1 equals 2, from word that equal to symbol come from. It was introduced by Robert Record in 1557, who got so tired of writing the word is equal to all the time in the maths textbook that he was writing that he decided to dedicate a symbol for it. He wrote, "To avoid the tedious repetition of these words is equal to, I will set, as I often do in work use, a pair of parallels or Gamow lines of equal length. Thus, is equal to, because no two things can be more equal. So is an equal sign because the two lines are of equal length." He thought that the two lines were so similar that they were like identical twins, which is why he called them Gamow, meaning twin. Gamow is derived from the old French word gamelle, which came from the Latin gemellus, and it is also related to the word for the astrological symbol Gemini, represented by twins. And the word equal comes from the Latin word aquus, meaning equal, flat, or calm. The origin of the minus sign is in early 15th century Europe. To represent addition and subtraction, the letters P and M were generally used with a line on top of it. The minus symbol may be derived from the line written over M when it was used to indicate subtraction, or it may come from a shorthand version of the letter M itself. Moving on to multiplication, the earliest use of the cross symbol appears in an anonymous appendix to the 1618 edition of the book by John Napier. This appendix has been attributed to William Oughtred, who used the same symbol in his 1631 algebra text. Using dots to represent multiplication was likely used by Thomas Harriot in his textbook published in 1631. This symbol was not prominently used until Leibniz, one of the inventors of calculus, adopted it. In a letter to John Bernoulli, Leibniz writes, "I do not like cross as a symbol for multiplication, as it's easily confounded with x. Often I simply relate two quantities by an interposed dot and indicate multiplication by zz dot lm. Hence, in designating ratio, I use not 1 point but 2 points, which I use at the same time for division." The earliest use of writing symbols side by side to represent multiplication was found in a manuscript in India dating to around the 8th century. We also use the star-like symbol called the asterisk. It's especially used in programming languages. Why is that the case? In the early days of computing, the keyboards were limited to a small character set, so the keyboards lacked a multiplication sign such as the cross or dot. But the asterisk symbol appeared on every keyboard, and it looked close enough to both the cross and the dot, and it also didn't have any mathematical meaning at the time. It was on keyboards for other uses such as for marking footnotes or separating sections. The first programming language to use asterisk to denote multiplication was Fortran in 1956. And then it was further adopted by other languages for consistency, and its use continued to this day. However, the symbol itself was actually first used by Johann Rahn in 1659 in Deutsche Algebra. He is also credited for the first use of this symbol to represent fractions, also known as the obelisk symbol, and the therefore symbol. Speaking of division, the word fraction comes from the Latin word fractio, meaning breaking into pieces. The earliest known use of fractions is in Egypt around 4000 years ago, but they only used fractions with 1 in the numerator. The modern expression of fractions, known as bhinnarashi, seems to have originated in India at least since 500 AD due to the work of Aryabhatta. Fractions were formed by writing numerators over denominators but didn't have a horizontal bar between them. For example, 6 and 1/4 was written as 614 vertically. And as Arabs traded with India, this notation spread there too. The horizontal fraction bar is first seen in the work of the Moroccan mathematician Al-Hassar in around 1200 AD, and then it spread to Europe. We use the slash symbol to representation in computers because, similar to the origin of the asterisk symbol, the slash symbol was a reasonable substitute to represent division in early computers, due to its similarity with the horizontal bar used for fractions. And with division, we can define ratios. Although nowadays rational numbers are defined in terms of ratios, the word rational is not derived from ratio. It's actually the opposite. The word ratio is defined from rational numbers. In fact, the word irrational came before both rational and ratio. A legend has it that the ancient Greek philosopher Hippasus was drowned at sea by the cult of Pythagoras for showing the existence of irrational numbers. I guess you can say that the people there were more irrational than the numbers. Euclid called irrational numbers by the word alogos, meaning illogical or unsayable. The word alogos was then translated into Latin as irrationalis, used for both mathematical and non-mathematical sense of the word irrational. The word rationalis, meaning rational, was back-formed from this. Then, as the words irrational and rational reached English, it seems that the word ratio was formed from rational. The word irrational was first attested in English in 1551, rational in 1570, and ratio in 1660. A percent is a ratio expressed as a fraction of 100, derived from the Latin word percentum, meaning by the 100. Centum here means 100, similar to how century means 100 years. And the symbol for percent probably comes from the shorthand for Italian word per cento. The current symbol with its two zeros on the top and bottom is a convenient reminder that the number in the denominator, which is 100, contains two zeros. When you have a ratio a by b, switching the places of the numerator and the denominator is called taking the reciprocal. For example, the reciprocal of 2 by 3 is 3 by 2, and the reciprocal of 2 is 1 by 2. The word comes from the Latin roots re, meaning backwards, pro, meaning forwards, and que, meaning and. So reciprocal means going back and forth. The numerator and denominator goes back and forth in the sense of switching places. Multiplying a number to itself is called squaring, because if you have a number s, then s times s gives you the area of the square with the side length of s. The name for the shape square comes from ex quadro in Latin, meaning square. Quadro is ultimately derived from the Proto-Indo-European word quatuor, meaning four. And a square has four sides. There are some words having a similar root word to square. The word quadratic in quadratic polynomial comes from the fact that its highest power is a square. The coordinate axis divides a plane into four pieces, so each piece is called a quadrant. A four-sided shape is called a quadrilateral. It comes from the Latin word quadrilaterus, where quadri means four and latus means side. It's a partial translation of the Greek word tetragon, which means four sides, but it's now completely replaced with the word quadrilateral. A number is cubed when it's multiplied by itself 3 times. If a number s is cubed, it gives the value of the volume of a cube with side length s. The word cube comes from the ancient Greek word kubos. The word cubic in cubic polynomial comes from the fact that the highest power is a cube. All these are examples of exponentiation. The word exponentiation has its root in the Latin word exponens, meaning to expose, ex meaning out or away, and pono meaning to place. When you expose something, you put it out so it can be seen. Similarly, in the mathematical notation, the exponent is a small number that you put out to the right and above the base when that base is being raised to a power. An exponent is therefore named after its physical appearance in writing rather than its mathematical significance. We use the word radical or nth root for 1 by nth power of number. The word radical has its root in the Latin word radix, meaning root. A radical reformer wants to eradicate societal problems right from its roots, often by means considered extreme, and as a consequence, any extremist may now be called a radical. In mathematics, the word comes from a translation of the Arabic word jadhr to Latin. Jadhr can mean root of a plant, but the mathematicians there used it in its other meaning of basis or foundation. Jadhr used to mean one unit of area used as the foundation to find the area of any rectangle. To calculate the entire area of a rectangle, you would count how many of these units you can fit into this rectangle. To find that, you would multiply a jadhr by one side length, then multiply that by the other side length. But eventually, this original meaning of jadhr was forgotten, and it came to mean the side length of a square given the area. In other words, the square root. And in this misunderstood form, it found its way to Latin as radix. And by the way, the word for the vegetable radish also comes from radix. I think that's enough information for one video. I might make another video on words used in algebra, geometry, and calculus and so on. Let me know if there is any word you would like me to cover.